The substance because of the Fukushima Daiichi nuclear disaster in Japan, and because most of my family resides in South Korea, many of them were kind of in shock or were kind of scared of like the fish that was contaminated in the EC, and that a lot of the fish that they consumed was from the EC. And I just wanted to see like the positives and the negatives of uranium as a power supply. So the chemistry of uranium, the physical properties. The color slash texture is silver gray and is hard. The standard physical state is solid. The melting slash boiling point is 1408 Kelvin and 4404 Kelvin. And the density is very dense with 19 grams per cubic centimeter, and is the heaviest naturally occurring element. The major isomers, it has three major isomers: uranium-238, uranium-235, and uranium-234. Reactions with light. In ultraviolet light, uranium fluoresces green, but when I looked into it, there was like no real reaction with light. Solubility in water. It's insoluble in water. The chemical properties. Uranium undergoes nuclear fission to create a large exothermic reaction, which the released heat is the main component in generating energy within nuclear power plants. This process of nuclear fission is created when the neutron is fired at a uranium atom and it splits, releasing large amounts of heat and energy. This will then cause a nuclear chain reaction where more neutrons will be released, causing for this process to repeat itself over and over again. Incompatibles of uranium is carbon tetrachloride, chlorine, fluorine, nitric acid, nitric oxide, selenium, sulfur, and water in finely divided form. Reacting with these substances can be dangerous. The three naturally occurring isotopes of uranium are radioactive, meaning that a nuclei spontaneously decays, and the radioactivity that is released from these isotopes cuts the alpha particles and gamma rays. When exposed to air, uranium metal will become coated with a layer of oxide. Uranium will be dissolved in acids but are unaffected by alkalis. When uranium metal is finally divided, it is attached by cold water and is pyrophoric, meaning it may spontaneously burst. This is a chemical formula of uranium and water. This is a nuclear fission, and the other one is properties of key uranium isotopes. This is a Lewis structure and the atomic information. This is uranium. Uranium was discovered by Martin Klaproth, a German chemist, in 1789, and he discovered it entirely accidentally in what is presently known as the Czech Republic. And Martin Klaproth gave the uranium its name after the planet Uranus, which was discovered around 8 years earlier. And Klaproth's discovery was made when he believed that zinc, when he was examining a pitch blade, which he thought was zinc or iron ore, and while studying this pitch blade, he would dissolve the substance in nitric acid and would then go to add a potash to get a yellow precipitate. And when this excess potash would dissolve this precipitate, and this reaction was not a common characteristic of this element, then this made Klaproth to conclude that he had discovered a new element, which is now uranium. And early uranium was used as a colorant for ceramic glazes and as a tinting agent in early photography. And it wasn't until 1886 the radioactive properties of uranium was discovered. So it was not until 1886 when the radioactive properties of uranium was first discovered, and it was not until the mid 20th century where the potential of uranium as an energy supply was manifested. With these new discoveries, uranium now is used to power commercial nuclear reactors, isotopes for medical uses, and defense purposes all over the world. Uranium is the main substance that is used by nuclear power plants that allow uranium to undergo nuclear fission, and this process releases heat and is used in turn to heat water and create steam. The steam is then used to spin large turbines and in turn generate energy. This form of energy is especially positive to people who live in environmentally challenged areas and is able to generate more energy than those other options such as hydro, wind, and solar. Uranium benefits people, providing effective energy to individuals without much difficulty. Uranium is also utilized in the military sector to power nuclear submarines and in nuclear weapons that provide security to citizens. Depleted uranium can also be used to counterweight aircraft, battleships, and can also be used in armor and ammunition because of its natural density. However, uranium does not only have positives, it also has drawbacks to society. This means that uranium is an extremely toxic substance, and uranium mining and exposure to the substance and consumption and inhalation can cause damage to an individual. It can lead to kidney damage, lung cancer, and other health drawbacks. Another drawback of uranium would be that the radioactivity of the substance lasts for a great amount of time. And this can be seen in the Hiroshima bombing in Japan, where many people died, and there was like an increased rates of cancer and other terminal illnesses due to the exposure to uranium. So the future impacts of uranium for our society, it seems that it will decrease because despite that it is very effective in providing energy, the uranium, and this can be seen like the uranium 235 can produce much more terajoules of energy compared to how much would energy it would take of coal to produce the same amount of energy. However, the peak of nuclear power plants was in 2006 and has been decreasing ever since. And this can be seen by the Atomic Energy Agency in 2020 projected the global nuclear generating capacity would increase from 392 GWE in 2019 to 475 GWE by 2030, 622 by 2040, and 715 by 2050, which is 4.5% of the generating capacity is nuclear in 2050, down from 5.3 in 2019. Despite the fact that nuclear power plants are effective in terms of carbon emissions are very green, the fact that the costs of power plants are high and the numerous delays in construction will lead to less nuclear power plants. And also, it looks like the health drawbacks are also a contributing factor. Environmental impact. Uranium has benefited the environment because it can create a large amount of energy without producing a large amount of carbon emissions. The only carbon emission I think it would be like the producing and the mining of the facilities and the burning or the nuclear fission. So however, according to the U.S. Energy Information Administration, even though these nuclear power plants do not directly produce carbon emissions, like there's indirect carbon emissions that it produces, and also it can damage the environment by the mining facilities produce tailings that are usually disposed of near surface impoundments. These tailings pose serious health and environmental danger with random emissions, windblown disposal, and the leaching contaminants, including materials such as heavy metals and arsenic into the water supply. And this kind of like damages the environment and like the underwater environment too, and can cause damage to humans because people can rely on these water sources. Another negative of uranium to our environment would be like the radioactive waste and like the accidents with the nuclear power plants that happened in the past, such as the Fukushima Daiichi nuclear power plant disaster, where an earthquake would destroy a couple reactors, and then there was a leakage of cesium-137, which is a common product of fission, and was released into the soil, which impaired food production in the region. And it also had drastic effects on the ocean, with much cesium isotopes becoming exposed to the water, and this could be found in the fish and the plankton living in these waters. So in the future, I think that because of the environmental impacts that it has, even though it does not create much carbon emissions, it will decrease because of all the other things, such as like the stigma around it with the Fukushima disaster and the Chernobyl disaster, and the fact that it was used in devastating weapons. And with the increased use of nuclear power would mean less mining of uranium and the creation of less reactors and mining facilities, which would in the end help the environment. And this would decrease the carbon emissions from these constructions and would decrease the environment from being impacted by radioactive material. And in terms of, I think that because of this, like the environmental impact would become less because there wouldn't be much more nuclear reactors in the first place because of these environmental impacts. So my action plan. Uranium is a substance that has incredible benefits by providing a manner in which energy can be made with little carbon emissions. Unlike other generation methods such as coal, it is able to produce more energy than renewable sources of energy such as hydro, wind, and solar. But despite these benefits, there are social impacts and environmental impacts to nuclear reactors and the use of uranium, such as in mining and the radioactive material. So what I would do is try to inform people that there are better options of energy, such as hydro, wind, and solar, and that there can be innovations made to the use of uranium to make it better suited to our environment. Thank you.